Inshallah, in today's class, we are going to start vector differentiation. So let me see the formulas which we are going to use in this. We are not going in detail concept theory because we are just doing the problems. No, see the formulas. The vector differential operator. This is called del. This is read as del. So vector operator is differential operator is del. Del. The formula of del will be I dou by dou x plus j dou by dou y plus k dou by dou z. The vector differential operator is del. Its formula is I dou by dou x plus j dou by dou y plus k dou by dou z. This is read as del. Now the next formula is, see here, if f is a scalar function, some function on a field, then gradient f is defined as del f. Gradient f is defined as del f. Shortly it is written as gradf, gradient f, grad f. So formula of gradient f will be del f. Formula of gradient f will be del f. How to solve the questions? Let me see in the questions just by heart. Gradient f is del f. Now del f will be the vector which is normal to the surface of the plane f. Surface f. Del f is a vector normal to the surface of given surface. Del f is a vector normal to the given surface. Now unit vector normal to the surface, its formula will be unit vector normal to the surface is del f by mod of del f. Del f by mod of del f. And directional derivative of f in the direction of a is del f dot a by mod a. Directional derivative. In short, we can write like this: directional derivative of f in the direction of a, vector a, in the direction of vector a is del f dot a by mod of a. In the direction of vector a is del f dot a by mod of del a. Just we have written 3-4 formulas. The first formula is gradient f del f, unit vector del f by mod of del f, and directional derivative of f in the direction of a is del f dot a by mod a. So let me do a few questions based on this formulas. Now let me start with an easy question. Find the gradient phi when phi is given by phi equals to 3x square y minus yx cube at the point. Point means this is x, y, z values. So let me start. Let me do everything. Let me first differentiate partially with respect to x, with respect to y, and with respect to z. What does it means? Partial differentiation of phi with respect to x. That is, we will differentiate x and y and z will be constants. Y and z will be constant. Partial differentiation means partial differentiation with respect to x. Y and z are constant. So you differentiate x square will be 2x. So 2 3 is 6xy. This will be. We don't have x here. That is, this is constant. So 0. Okay. In the same way, dou phi by dou y. Now with respect to y means x and z are constants. We will not differentiate x and z. Just you differentiate y. D by dy of y will be 1. 1 into 3x square, 3x square. As y cube will be 3y square. So 3y square, z square as it is. First term, second term, then third term. What is the third term? Dou z by dou phi by dou z. With respect to z, we don't have z in this. This is constant 0. Okay. Now in the second term, z square will be 2z. D by dz of z square 2z. So 2 will come here, minus 2y cube z. Therefore, what is the formula of z? So what is the formula of gradient f? We want gradient phi. Gradient phi is del phi. Gradient phi is del phi. Now what is the formula of del phi? You see here what we have written: I dou phi by dou x. Acha, we have not written there, no? This is the formula: I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. So this is the formula: I dou phi by dou x. Del is, you see here, what is the formula of del? I dou by dou x plus j dou by dou y plus k dou by dou z of f phi. So you multiply phi. I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z equals to, now let me substitute the values, equals to I into what is dou phi by dou x? This 6xy plus dou phi by plus j into dou phi by dou z. Dou phi by dou z is 3x square minus 3y square z square, this one, plus k into dou phi by dou z is minus 2y cube z But you see here point is given. Let me substitute this point x, y, z, 1 minus 2 minus 1. Lord, let me substitute 1 minus 2 minus 1. X, y, z. Now you see substitute 1 here and minus 2. Plus into minus 2 6 are 12. Minus 12i. Now let me substitute here plus j into x square 1 square. 1 square into 3 is 3. Minus y square means minus 2 square minus 1 square. 2 square 4. 4 3 are 12. Minus 12 into j. J already you know. Plus k into. Now if you substitute here, what's here? Minus 2 into y cube. Minus 1 cube is minus into minus plus 2. Plus into minus 2 to 4. These are the numbers you substitute by yourself. This will be minus 12i minus 9j minus 4k. I think we done here. Sorry, y is minus 2. Minus 2 cube will be 8. 8 to the 16. 16 into minus 1 minus 16. I think this is minus 16. This is minus 16. So you change this one. This will be minus 16. Okay. Now let me see. Find a unit vector normal to the surface. Solution. Let me denote surface by phi. Phi equals, right, like this: x cube plus y cube plus 3xyz minus 3. Okay. At the point means 1, 2, minus 1. This can substitute the values x, y, z. No, unit vector normal. We know the formula. What is formula? Unit vector normal to surface. Normal to surface phi. What is the formula? Del phi by mod of del phi. Let me do one thing. Let me find del phi, then mod of del phi, then let me substitute the formula. So phi we are already having now. We have to let me differentiate 3 times. With first with respect to x, dou phi by dou x. With respect to x means x cube will be 3x square. We don't have x here, 0. X differentiate 1. 1 into yz is 3yz, 3yz. Now I am substituting the point also. 1 square, x is 1. 1 square into 3 is 3yz. 2 minus 1. 3 2s are 6. 6 into minus 1 minus 6. This is minus 3. In the same way, dou phi by dou y. With respect to y, we don't have y here, 0. Y cube will be 3y square. D by dy of y is 1. 1 into 3xz, 3xz. This is constant 0. Now let me substitute the value. Let me substitute y. Y is 2 here. So if you substitute 2 here, 2 square 4. 4 3 is 12. Plus 3 into 1 into minus 1 minus 3. Plus into minus 3. 9 minus 3. Sorry, 6. 12 minus 9 is 3. Now lastly, dou phi by dou z. Now with respect to z, we don't have z here 0. We don't have z here 0. Now d by dz of z will be 1. 1 into 3xy, 3xy. Now substitute the values. 3 into x is 1, y is 2, 3 2s are 6. So we got the values. Therefore, what is del f? Del f. The formula of del phi is I dou f dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. Now let me substitute the values. Dou phi by dou x is minus 3. So this will be minus 3i plus this is 9, 9j plus 6k. Now let me find its magnitude. What is the meaning of mod? Mod means magnitude, the value of is it. Therefore, mod of that phi. When we take mod, we have to take this its squares in the root. Its squares in the root, not I. I coefficient is minus 3. So minus 3 square plus 3 minus 3 square plus 9 square plus 6 square. Let me do one thing. Let me take common 3 square from all this. If we take 3 square common, minus square will become plus 3 ones are, so we left with here 1 square. 3 3s are, we left with 3 square. 3 2s are, we left with 2 square. So this square and root get cancelled. What is left here? 3 into under root of. This square and root get cancelled. 9 plus 1, 10. 10 plus 4, 14. Therefore, del f, we are having formula del phi by mod of del phi. Mod of del phi. Let me substitute the values. Del phi. Del phi we got minus 3i plus 9j plus 6k by mod value is 3 root 14. Let we take 3 common. If you take 3 common, the 3 will get cancelled. What is left? Minus I plus 3j plus 2k divided by 3 under root of 14. 3 3 get cancelled. What is left here? Minus I plus 3j plus 2k by under root of 14. Now you see the next question. Find the directional derivative. Find the directional derivative. Find the directional derivative of f equals to xy plus yz plus zk in the direction of vector. Suppose the given factor is f and the given function is f and the vector, let I denote this by a. So this is I plus 2g plus 2k. What is the point 1 comma 2 comma 0? Suppose this is x y z. Now let me first write the formula directional derivative of f in the direction of a. What we wrote the formula? Del f dot a by mod of del f. Del f dot a by mod of del f. First let me find del f, then we use the formula. Okay, first for del f we have to differentiate this partially with respect to x. Dou f by dou x, d by dx of x is 1, 1 into y is y, plus we don't have x here is 0, d by dx of 1 is x is 1, 1 into z is z, so y is 2 here, 2 plus 0 equals to 2. Now next one is dou by dou y, dou by dou y, dou f by dou y with respect to y. Y differentiation 1, 1 into x is x, y is 1, 1 into z is z, constant is 0, so x plus z, 1 plus 0 is 1. Now dou f by dou z with respect to z, we don't have z here, 0, 1 z, 1 into y is y plus x, so 1 plus 2 is 3. Therefore del f will get del f equals to, what is the formula? I dou f by dou x. Dou f by dou x is 2, 2 into I plus j into dou f by dou y, 1 into k, j is j, plus lastly plus, what is the formula next? K. Dou z by dou f by dou z is 3k. So we got del f. Now let me substitute the formula. What is the formula here? Therefore del f dot a by mod a equals to del f is 2i plus j plus 3k dot a is the given vector. What is the given vector? I plus 2j plus 2k divided by mod. Now see here, mod, what does it mean? Mod means magnitude. Magnitude of a. Magnitude of a means under root of, you have to take the squares. 1 square, coefficient square, 2 square, 2 square. Now how to find the dot product? Dot product means we have to multiply 2 I coefficients, 2 j coefficients, 2 k coefficients. First let me multiply I coefficients. So 2 1s are 2, then j coefficients 1 2s are 2, plus k coefficient 3 2s are 6, divided by under root of 4 plus 4 8, 8 plus 1 9. This is 10 by 3. 10 by 3. Now see the next question. Find the direction derivative of f equals to x square minus y square plus 2 square at the point p 1 comma 2 comma 3 in the direction of pq. In the direction of pq, where q is 5 comma 0 comma 4. You see here, f is given point. If we want to show in vector form, we, that is actually, this is called position vector of point p. We have to denote like this: op equals to, I am denoting this in vector form, I plus 2j plus 3. In the same way, the point q can be written as vector form oq, phi I, j is 0 plus 4k. Now what is the question? In the direction of pq, the direction differentiation of f in the direction of pq equals to, what's the formula? Del f dot a, in place of a we have to write pq, divided by mod of pq, divided by mod of pq. So what are the things we have to find? First let me find del f, then pq, then mod of pq. Now let for del f we have to find dou f by dou x. Now with respect to x means x square is 2x. We don't have x here, 0. X value is 1, 2 ones are 2, so we got dou f by dou x. Now dou f by dou y with respect to y, this is 0, this is 0, minus 2y, minus 2 2s are 4. Now dou f by dou z, dou f by dou z with respect to z, z square is 2z, 2 2s are 4z, and z is 3, 4 3s are 12. Now we got del f. What is the formula of del f? Del f equals to I dou f by dou x, I dou f by dou x plus j dou f by dou y plus k dou f by dou z. Now let me substitute the values. We get the value of del f. Now del f equals to I into 2, that is 2i minus 4j minus plus 12. Now we got del f. Now next step we have to find pq. Watch carefully. We do watch carefully. Suppose a vector ab we are having. So vector ab formula is ob minus oa. Position vector of b minus position vector of a. AB can be written as OB minus OA. In the same way, tell here PQ can be written as OQ minus OP. So OQ value is given in the question. This is 5i plus 4k. Minus OP means multiply minus with OP. This will be minus I minus 2j minus 3. Now let's substitute this 5i minus 4 minus I will be 4i minus 2j. 4k minus k will be plus k. So let me substitute in the formula. What is the formula we are having? Del f dot pq by mod of pq. So del f we got just now this value here, 2i minus 4j plus 12k dot pq. The value of pq is 4i minus 2j plus k divided by mod means under root of squares of this, 4 square plus minus 2 square plus 1 square. What is the meaning of dot product? We have to multiply the coefficients of I, J, K. 2 4s are 8, minus into minus plus 4 2s are 8 plus 12 1s are 12 divided by under root of 14, 16 plus 4 20, 21. So this is 12, 20, 28. 28 by root of 21. We can change into 7 products, we can solve, or we can leave here itself. So this is the direction derivative. Now see here, find the direction derivative of x, y, z square plus xz at the point 1, 1 in the direction of, here not directly the question is given, but in the direction of normal to the surface. So first we have to find normal to the surface. Normal, that is suppose a, then we have the formula del f dot a by mod of del f. First we have to find normal to the surface. Let me do one thing. I am denoting this by f. Let f equals to xyz square plus xz. Okay, and this surface suppose I am denoting by g. G equals to 3xy square plus y minus z. Bring the z on the other side. Bring the z on the other side. So this will be, what is the value here? 3, just wait, function is 3xy square plus y equals to z at the point. So let first we find the normal of g. At what point we have to take? 0, 1, comma. So normal of g will be normal of g equals to del g. Del g, sorry, normal of g will be del g, because it is not given directly from vector, but it is given normal to the surface. So we have to take first normal to the surface. Let me first find this one. So this will be I dou g by dou x plus j dou g by dou y plus k dou g by dou z equals to, watch carefully, I into, with respect to x, differentiate this with respect to x. X is 1, 1 into 3y square is 3y square plus j into dou g by dou y. With respect to y, y square is 2y. So this will be 2 3 is 6xy, 6xy plus d by dy of y will be 1, constant is 0. With respect to y, y square is 2y, 2 3 is 6xy plus y is 1 1 plus k into dou y dou z. With respect to z, 0 0, z is 1 minus 1. Now let me substitute the values. Y is 1 here, 1 square 1, 1 3 is 3. So this will be 3i plus, now this x is 0, so this is 0, 1, 0 plus 1 is 1, 1 into j is j minus k. So let me denote this by a. Let a equals to 3i plus j minus k. Now we have to find the direction derivative of f. F is xyz square plus xz at the point 1, 1, 1. So direction derivative formula is del f dot a by mod of del. So let me find do it. Otherwise, you directly use the formula directional derivative of f in the direction of a. Its formula is del f dot a by mod a. Let me first find del f. So del f will be I dou f by dou x plus j dou f by dou y plus k dou f by dou z I into dou f by dou x with respect to x. So d by dx of x will be 1. 1 into yz square is yz square plus j into dou f by dou y. With respect to y, y is 1. 1 into xz square, xz square plus k into dou f by dou z. Here z square is 2z, so this will be 2xyz plus z is 1. 1 into x is x. Now the point is 1, 1, 1, x is 1, y is 1, z is 1. So we will get del f. If you keep y1, z1, it's will be 1 into I, vector I. This is 1, this is 1, so j plus j. 2 plus 1, 3 plus 3k. Now we got del f. So what is the formula we are having? Del f dot a by mod a. So that equals to del f. The value of del f is just now we have done I plus j plus 3k dot a. The value of a is here 3I plus j minus k by mod of a means under root of square 3 square 9 plus 1 plus 1. What is dot product? Multiply the coefficients of I, j, k. 1 3 is 3 plus 1 1 is 1 minus 3 1 is 3 by under root of 9 10 11. So this will get cancelled. What is left here? 1 by root 11. 1 by root 11. So this is the first class easy questions we have done. The vector differentiation is an easy topic, whereas vector integrals we are having some tough questions there, but vector differentiation is very easy. So inshallah in the next class we are going to continue with the angle between the planes and what is solenoidal and irrotational questions and what is divergence. Let me see in the next part inshallah. So I request all the students to subscribe my channel and share and like my channel inshallah. We will continue in the next class.